right, 13.5 regarding controllers. SDN controller and operation. Yeah. Defines the data flows between the centralized control plane and the data plane on individual routers and switches. Each flow traveling through the network must first get permission from the controller or from the SDN controller, yeah, which verifies that the communication is permissible according to the network policy. All right. All complex functions are performed by the controller. The controller populates flow tables and switches manage the flow table as well. All right. Okay. Within each switch, a single table implemented in hardware or firmware are used to manage the flow of packet through the switch. To the switch, a flow is a sequence of packet that matches a specific entry in a flow table. Okay, there are three tables type shown in the previous figure. First, flow table. Second, group table. Third, meter tables. Flow table. This table match incoming packet to a particular flow and specify the function that are to be performed on the packet. There may be multiple flow tables that operate in a pipeline fashion. Okay. So a group of table. A flow table may directly a flow of a group table, which may trigger a variety of action that affect one or more flows. This table, and then for the meter table, yeah, actually it will triggers a variety of performance-related action on a flow, including the ability to rate limit the traffic. All right. So this is tree table. Okay. And now we will see the video regarding Cisco ACI. All right. So very few organizations actually have the desire or skill to program a network using SDN tools. And also there is research going on a lot on SDN. If you look in the journals, lots of talking about this recently, SDN, very powerful. However, the majority of organizations want to automate the network, accelerate application deployment, align their infrastructure to be better meet business requirement. And Cisco comes, this solution, ACI, Cisco ACI, using this SDN. Cisco develop application-centric infrastructure. Stand for, for the short form is ACI, application-centric infrastructure, to meet this objective in more advanced and innovative ways than earlier SDN approaches. Then in Cisco ACI is a hardware solution for integrating cloud, computing, and data center together, and at high level, the policy element of the network is removed from the data plane. This simplifies the way data center network are created. All right. So now we have looked at the video for this regarding Cisco ACI.
How did we get here? We used to network. all separate silos. In fact, compute had its own silos. Servers were local to the users. They were grouped by function, right? We had mail servers, database servers, and so on. Then we had higher speed wide area networks, which brought us data center consolidation. How did we get here? We used to keep everything in silos, nice and neat, right? We had storage, and then we had compute and network, all separate silos. In fact, compute had its own silos. Servers were local to the users, and they were grouped by function, right? We had mail servers, database servers, and so on. Then we had higher speed wide area networks, which brought us data center consolidation. We started moving all of our eggs into some very well air conditioned baskets. And then came virtualization, the hypervisor. Probably our biggest jump ever for optimization. Now one server could run multiple operating systems. Applications could think that they were still siloed. Well, that then brought us up multi-tenant data centers. Now compute could be offered as a service to your own enterprise or others. Here's a challenge. This hyper virtualization has created what I call separation anxiety. You see, virtual machines grow like weeds. They're very portable, and we can do a lot of great things with them. But the network insists that your identity, thus your policy, is tied to where you're located. Well, VLAN, subnets, security rules, and old-fashioned manual labor, these kind of things have kept it flowing for quite a while. But the complexity has reached a tipping point, and anxiety has firmly set in. Success can only be achieved when there's a harmony between the applications and the network, because they're both critical. Now, many answers have been proposed. In fact, two worth highlighting here: software-defined networking, or SDN, and network virtualization. SDN, though, means different things to different people. In general, it's some kind of abstraction between the control and the data planes, but there's a new element called the SDN controller. This is another bit of software here that should handle all the instructions between the applications and the network. This is all good work. It's interesting concepts. They're worth pursuing, but they fail to solve the problem. The SDN band-aid is ultimately just another layer of complexity. Now take network virtualization, which pretends the network is not really there. Just encapsulate everything on layer 3 and drive with your eyes closed. Complexity still remains, even if it is harder to see. It's just a different kind of band-aid. So true abstraction, isolation, and independence are needed for the network to truly support these dynamic workloads. And to truly get rid of the complexity, we need a do-over. Well, to do it over right, we need to follow a couple of requirements here. First off, the application must come first. There's no reason anything else exists except to support the apps. But also, applications cannot be touched, period. Don't touch them. And the third one, however, is keep it simple. I mean, some engineers know their apps. We got our app experts. Some engineers know their network. Both of these guys are valuable, and they need to be able to communicate very easily for this kind of thing to work. Well, Cisco's application-centric infrastructure has achieved all of this. Let's look at just 3 ACI concepts to help get you started: application network profiles, fabric, and stateless hardware. First, what is an application? It's not as singular as you would think. A simple web application has at least 3 logical tiers. Users interact with a web tier that will then talk to back-end application and database tiers. So is that the app? Not yet. Now you have network services functions between each of these tiers, like QoS, load balancing, security. In a nutshell, it's all the policies, right? Take Oracle, for example. I mean, it could easily have different personalities on the network. Is it development? Is it test? Or is it production? I mean, all of those look the same to the network, yet each need dramatically different policies. Well, ACI wraps all of this up in an application network profile. It's a logical mapping of how an application is going to look, connect, and be treated anywhere on the network. Suddenly, we have one simple interaction point for an app developer, a network engineer, heck, even management. Well, this policy now sticks with the app as it moves through every part of its life cycle. And when you're done with the app, all of its policy stuff disappears. None of that stuff stays on your network. It stays clean. The ACI fabric, which is our second concept here, is made up of the Application Policy Infrastructure Controller, the APIC, plus those stateless hardware switches, our third concept. So the switch architecture is a leaf spine layout that enables linear scalability and robust multipathing, completely optimized for east-west traffic so common to data center applications. And it scales so easily. In fact, each spine switch you add creates another network path available for load balancing. And it's a very open design too. The APIC exposes a northbound API for access to all the control functions. The southbound API opens up third-party network services for even more policy control. These application profiles are used by the APIC to push logical topology and policy definitions down to that stateless hardware. This is a complete reversal from traditional architecture where ties between VLANs, subnets, and firewall rules are tightly coupled, trying to meet dynamic application needs. ACI is a complete system, but without the complexity. Traverse any path in the network as if it was all virtual machines, layer 2 adjacency. Seamless mobility across physical, virtual, even geographically dispersed endpoints. Top-down control, bottom-up visibility with real-time telemetry and atomic counters. It's like an overnight success, 30 years in the making. ACI makes a lot of sense.
All right. Okay. That's regarding Cisco ACI. So core component of ACI. Yeah. Okay, there are three component, three core component of ACI architecture made by Cisco. First, they call Application Network Profile, ANP. ANP is a collection of endpoint groups, or EPG, their connection policies that define those connections. Second, Component Application Policy Infrastructure Controller, APIC, API-C. So API-C is a centralized software controller that manage and operate a scalable ACI cluster fabric. It is designed for programmability and centralized management. It translates application policies into network programming. And third component, Cisco Nexus 9000 series switches. These switches provide an application-aware switching fabric and work with an APIC to manage the virtual and physical network infrastructure. So means that ACI provide the software and also provide the hardware as well. So the APIC is a position between APN and the ACI enabled network infrastructure. The APIC translate the application requirement into a network configuration to meet those needs. All right. So this is the structure, architecture of the ACI. Spine leaf topology. Okay. Where is a spine? This is spine. This is a leaf. Because spin and life. This is hardware. Okay. All right. This is APIC. This is software. This is software. This two is a what? Hardware. Okay. The Cisco ACI fabric is composed of the APIC and Cisco Nexus 9000 series switches using two tiers, spine and leaf topology. Okay. Like you see in the figure. Yeah. All right. The leaf switches attached to the spine. The leaf switches here. All right. The leaf switches. But they never attach to each other. All right. So no link in between that. Okay. No link. No link. Yeah. We can see that. All right. Yeah. Okay. Similar, the spine switches only attached to the leaf and core switches. In this two-tier topology, everything is one hop from everything else. Yeah. When compared to SDN, the APIC controller does not manipulate the data path directly. Instead, the APIC centralizes the policy definition and programs the leaf switches to forward traffic based on the defined policies. SDN type. The Cisco Application Policy Infrastructure Controller Enterprise Module, EPIC EM, yeah, extend SCI, enterprise and also campus deployment. Okay, scalable. Go to the big market. To better understand EPIC EM, yeah, it is helpful to take a broader look at the three type of SDN. First, device-based SDN. So devices are programmable by application running on the device itself or on a server in the network, as shown in the figure below here. Yeah. And then second, controller-based SDN. Use a centralized controller that has knowledge of all devices in the network, as shown in figure below. The application can interface with the controller responsible for managing devices and manipulating traffic flows throughout the network. So the Cisco Open SDN, yeah, Cisco Open SDN controller, all right, is the commercial distribution of Open Daylight. All right. So this is the one. Okay, controller-based SDN. So another one, policy-based SDN, similar to controller-based SDN, where a centralized controller has the view of all devices in the network, as shown in the figure. Right? Policy-based SDN includes an additional policy layer that operate at a higher level of abstraction. It uses built-in application that automate advanced configuration tasks through guided workflow and user-friendly GUI. No programming skill are required for this, and Cisco FPEM is an example of this type of SDN. All right, based on policy base. Okay, EPIC EM features. Okay, EPIC EM, yeah, features, yeah, provide a single interface for network management, including first discovering and accessing device and host inventories, viewing the topology, you can see here, okay, tracing a path between endpoint and setting policies, right? So path trace on EPIC EM. The EPIC EM path trace tool allows the administrator to easily visualize traffic flow and discover any conflicting, duplicate or shadow all ACL entries. This tool actually examines specific ACL on the path between two end nodes, displaying any potential issue. You can see where any ACL along the path either permitted or deny your traffic, as shown in the figure. Right? Notice how branch router 2 is permit all traffic. The network administrator can now make adjustment if necessary to better filter traffic. So this is the screenshot of that ACI enterprise menu. Sorry, enterprise module. Yeah. All right, that's all for regarding virtualization. All right, thank you.